Alright, welcome back. So that last lecture was 8A, this is lecture 8B. So I want to talk about timers 1, 2, and 3. Timer 1, very similar to timer 0. So here's the control register, T1 con. You start the timer by setting timer 1 on to be a 1. Okay, that enables the timer. No big surprise there. Your clock select is controlled by bit 1. That should be a 0. That sets the internal clock to be the system oscillator, right? Frequency of the oscillator. The system clock divided by 4. So that's your 8,000 ticks per second. Bit 2 is ignored when we're setting bit 1 to a 0. So bit 2 doesn't matter. Bit 3 set to a 0. Okay, we don't need to use this timer 1 oscillator. That's something different. We're not going to mess with that. So leave that at a 0. Bits 5 and 4 control a prescaler, same prescaler that we have with timer 0, but we only have 4 options, no prescaler, or 1 to 2, 4, or 8. Bit 6 is read only, so that's not important to us. Bit 7 we want to go ahead and set to a 1. That lets us do this reading and writing of the 16-bit timer register in a way that lets us basically read or write both bytes simultaneously. And remember, there's a protocol we have to follow. When you're reading timer 1 high and low, you have to read the low piece first. When you're writing a value, you have to write the high piece first. Okay, that's important. Now that works with read 16 being a 1. So you want this to be a 1. This doesn't matter. This is your prescaler. Your oscillator we can leave shut off. Your sync doesn't matter. Your chip select should be a 0, and this is a 1 or a 0 when you want to turn the timer on or off. Other than that, this timer works basically exactly like timer 0. It's a 16-bit counter. We can't put it in 8-bit mode, so it's always a 16-bit, so it overflows at 65, 536, right? It fills up at 65, 535, overflows after one more tick. You can load an initial value into it. You can control how many times it takes the instruction clock to tick before it increments the timer 1 register by choosing the prescaler value. And when it overflows, it generates an interrupt. Okay, so timer 1, let's see, timer 1 interrupt flag, interrupt enable, and interrupt priority are controlled in bit 0 of the PIR1, PIE1, and IPR1 registers. No rhyme or reason to that, you just have to refer to the data sheet. Right? Remember, IF is the bit that's turned on when an interrupt is being requested. IE is what allows the system to request an interrupt when IF is 1, and IP lets us choose whether it's high priority or low priority. And then timer 1 H and L are the 2 bytes of the 16-bit timer 1 register, and T1 con we just looked at. And int con is for enabling high and low priority interrupts as usual. So that's timer 1. Timer 2 is a little different. So timer 2 has a neat feature to it. Here's the thing. We want to take our timer, so consider timer 0 for example. And suppose we want to generate an interrupt after 1/1000th of a second, or 8 thousandths. So what we want to do is we want to get 8 ticks of the clock, and then we want to generate an interrupt. So the way to do this would be to initialize timer 0. Let's say it's a 8-bit. Let's say we do 8-bit operation. If we look at 256 minus 8, which is going to be 248, if we load that into timer 0L, and we have a 1-to-1 prescaler, so forget about the prescaler monkey. After 8 ticks of the instruction clock, each taking an 8,000th of a second, this will have incremented to 256, which is an overflow, which generates an interrupt. So it's very easy, if we do the math, to set up the timer like timer 0 or 1 to say, hey, I want an interrupt after a certain amount of time. The problem is, once that interrupt occurs, remember, this bucket gets emptied and it becomes a 0. And if we don't do anything else, we're not going to get an interrupt in another 8 instruction cycle ticks. It's going to take 256 instruction cycle ticks to get the next interrupt. So in our interrupt code, we need to do something to say, hey, this timer 0L has got a 0. Let's load a 248 into it again. But that's a little inconvenient. Plus, we don't know how long it takes to actually get into our interrupt code. So it would be nice if there was a way that this could automatically get reloaded to some magic preset value. So this is the idea of timer 2. Timer 2 looks basically the same in the control register. So there's a 2-bit prescaler, 1 to 1, 1 to 4, or 1 to 16. There's also a 4-bit postscaler, these 4 bits, 6 through 3. Basically multiply the prescaler and postscaler together to get what the actual multiplier is. And it's turned on or off with bit 2, so that's the timer 2 on bit, and we don't use bit 7. Okay, but there's another register we use with timer 2, and this is the Pr2 register. So Pr2 is an 8-bit register, and here's the idea. All the other timers, they overflow. If it's an 8-bit mode, they overflow when the timer reaches 256, right? Because that exceeds what you can store in 8 bits. Timer 2 is different. Timer 2 generates an interrupt when the timer 2 register is equal to another special function register called Pr2. It's a preset register. So we can load any value we want into Pr2. Timer 2 increments each time that the instruction cycle ticks, modified by the prescaler. But when timer 2 is equal to Pr2, that's when the interrupt occurs. So in that previous example, we wanted to generate an interrupt after 8 ticks. Here's how we would do it. We would set timer 2 to be 0, but we would set Pr2 to be 8. And now, after 8 instruction cycle ticks, this will get incremented to the value of 8. Once it's equal to Pr2, bang, that triggers the interrupt, and it resets timer 2 to a 0. So without doing anything in our code, now, 8 instruction ticks later, this is going to be 8 again, we're going to get another interrupt. And it's going to get reset to 0, and 8 instruction cycles later, it's going to have incremented 1, 2, 3, 4, 5, 6, 7 back to 8, matches Pr2, we get another interrupt, it goes back to 0. So we can set timer 2 up to generate interrupts at a regular interval. Okay, the size of that interval, that's determined by this Pr2 setting. And every time that timer 2 has incremented to the value of Pr2, it generates an interrupt request, and it resets timer 2 to a 0. So that's the period register, right? And then that interrupt request coming out of the comparator actually goes through the postscaler. But like I say, you can think of the postscaler and prescaler as being multiplied and slowing down how often we increment timer 2. So other than that, timer 2 is basically like timer 1 and 0. But this is a significant difference, right? We load an interval into Pr2, and the interrupt occurs whenever timer 2 increments to this value, and then it gets reset to 0. If we set Pr2 to 0, it's basically acting like timer 0 or timer 1. It will increment until it rolls over to 0, and that's when it will generate an interrupt request. But this lets us do intervals at a predetermined fixed period, and that's going to be convenient in what we talk about in the next lectures 9, when we talk about pulse width modulation. All right, so that's timer 2. Timer 3 is not on your handout, but it's pretty much the same deal. So timer 3 is a 16-bit register. Set read 16 to 1, right, so that it understands 16-bit operations. It's got a set of prescaler values we can choose. We don't care about bit 3. Bit 2 we can set to a 0. Bit 1 we're going to set to a 0, so that we're using the internal clock, right, system clock divided by 4, and bit 0 enables or disables. And the timer 3 register, TMR3, which has a high and a low piece, that's the 16-bit register that keeps getting incremented, and when it overflows, that's when the interrupt request occurs. Okay, basically exactly the same thing as timer 1 and timer 2. And to deal with the interrupts, right, so timer 3's interrupt flag, interrupt enable, and interrupt priority are bit 1 in these PIR2, PIE2, and IPR2 registers. Timer 3 low and high, those are the low and high bytes of the actual timing register. There's the configuration register for T3 con, and we don't care about T1 con with the settings we've been using. That's pretty much it. That's the whole setup of the 4 timers on the PIC processor. So take a look at the homework questions, use your notes, and think about those, and we will work through mainly timer 0 in the beginning of class Monday, and then we'll go through these other timers as well.